Hello everyone, welcome to Maths with Mr. J, and today we are going to learn about the sum of the first n term of linear sequence or arithmetic progression known as AP. The sum of the first n term of linear sequence is given by Sn equal to n over 2 into 2a plus n minus 1 in bracket times d, all in brackets, where n is equals to the first n term, a equals to the first term, and d is the common difference. We still have alternative formula of sum of the first term of arithmetic progression when we know the last term is given as Sn equal to n all over 2 into a plus l, which means the last term. Now let's take an example. Using the formula of finding the n term of an AP, which is Sn equal to n over 2 into 2a plus n minus 1 d, bracket close, where n is equals to 5, a is equal to first term, which is 2, d is the common difference, which is preceding term, which is 6 minus 2 gives us 4, 10 minus 6 gives us 4, 14 minus 10 gives us 4, 18 minus 14 gives us 4. So 4 is the common difference. What we do, we substitute 5, 2, 4 in place of n, a, and d, respectively, into the formula. That is S5 equal to 5 over 2 into 2 times a, which is 2, plus bracket 5 minus 1 times d, which is 4. Bracket close. Then if we continue, we have 5 over 2 into 2 times 2 gives us 4, plus 5 minus 1 gives us another 4, times 4 give us 5 over 2 into 4 plus 4 times 4, which gives us 16. We have 5 over 2 into 4 plus 16 gives us 20. 2 into 2 gives us 1, 2 into 20 gives us 10, 10 times 5 gives us 50, which is the answer. We can use the alternative method, which is Sn equal to n over 2 into a plus l, where n is equal to 5, a is equal to 2, and l is equal to, we go back and check the last term given. The last term given is a 10. A 10 is the last term, which is a 10. Let's substitute n equals to 5, a equals to 2, and l equals to a 10, and see if we get the same answer as 50. Then we continue. We have x5 equal to 5 over 2 into a is 2 plus the last term, which is a 10. Then x5 is equals to 5 over 2. 2 plus a 10 gives us 20. 2 cancel 20 gives us 10. 10 times 5, which gives us 50, which is the answer. Now we can check if our answer is correct. What we do, we list all the sequence or all the terms in the sequence, which are 2, 6, 10, 14, and 18. Now let's sum all the terms up and see if we get 50. That is 2 plus 6 plus 10 plus 14 plus 18. Will it give us 50? 2 plus 18 gives us 20. 6 plus 14 gives us another 20, which is 40, plus 10, which is equal to 50. So our answer is correct. Now we take another example using the same sequence. Example 2 is similar to example 1. We have the same sequence, but the only difference is that we are going to find the first 101 term of the AP. This is where the formula becomes very, very important, because we cannot list all the 101 terms to add it together. Then we use the formula. We have solution Sn equal to n over 2 into 2a plus n minus 1 times d. We continue where n equals to 101, a equals to 2, and d is equal to 4. When we substitute this into the formula, we have x101 equal to 101 over 2 into 2 times a, which is 2, plus bracket 101 minus 1 times 4. This will give us 101 over 2 into 2 times 2 gives us 4, plus 101 minus 1 gives us 100 times 4, which will give us 101 over 2 into 4 plus 100 times 4 gives us 400. We have 101 over 2 into 400 plus 4 gives us 404. Divide by 2. 2 into 2, 1. 2 into 404 gives us 202. 101 times 202 will give us 20,402 if you use your calculator. So this is where the formula is very, very useful when taking the sum of the terms. The second formula cannot be used because we don't know the last term. If this helped, please subscribe, like, and share. Thank you very much. See you in my next video.